In this video, we are going to see the priority scheduling in a preemptive mode. So in the previous video, I have explained about how the priority scheduling algorithm works in a non-preemptive mode. So here we are going to see the same algorithm in a preemptive mode. So here they have given the priority values of each and every process and the arrival time as well as the burst time. So as you know, first we have to draw the Gantt chart. So in this, if you see, the first process to come in at the 0th millisecond, if you see in this example, at the 0th millisecond, the first process to come in is your P1. Even it has the priority value as 2, but at 0th millisecond, the process that is coming in is P1. No other process is waiting there in a queue. That's why there is no comparison with the priority right now. So P1 is coming in at 0th millisecond and it is executing. So when it keeps on executing, so when it reaches the 2 millisecond, at that particular point of time, P2 arrives. Okay, P2 arrives. Now the process P2 is having the priority priority 1, priority value as 1. Now, as of now, P1 is having the CPU. P1 is executing. At the second millisecond, process P2 is coming in now with the priority 1. When compared to the process P1, P2's priority is higher. So whenever the P2's priority is higher, because we are in a preemptive mode, what the CPU has to do, CPU has to stop the execution of process P1 and takes the process P2 and it has to execute that particular process. So as you see here, it has completed 2 milliseconds. Okay, it has completed 2 milliseconds. So 8 milliseconds left out. And now P2 is having the highest process. So P2 is taking the CPU now. So P2 is started, P2 starts its execution. Now P2 is executing. Meanwhile, so after 1 millisecond, P3 is coming. Okay, after 1 millisecond, P3 is coming now. So P3 is having the value of 0, priority value as 0, which is higher when compared to the process that is currently executing. Which process is currently executing? P2 is currently executing. So what the CPU has to do? CPU has to throw the P2 out and take the P3 in and give the CPU to it. Okay, and give the CPU to it. So it has executed for only 1 millisecond. That means 4 milliseconds left out. So now the CPU is given to the process P3. So P2 has executed for only 1 millisecond. Now the CPU has been handed over to process P3. P3 starts its execution. So when the 4th millisecond arrives, your P4 process is coming in. Now P3 is currently running in the CPU. Now process P4 is there. P4's priority is smaller when compared to P3, so there is no swap. So your P3 is given the CPU and it will complete its execution till it completes its execution. Now you see P3 is executing for finishing its execution. So it is becoming 0. So it has executed for 2 milliseconds. So it will be 5. Now we have to decide. Now in your queue, we have process P1, we have process P2, and we have process P4, and the corresponding priorities are there. So you have to see which is having the lowest priority. As of now, your P3 is over. This is over. Okay, your P3 is over. We have 3 more processes left out. In this, which is having the highest priority? P2 is having the highest priority. Now P2 will be given the CPU. So you have 4 more milliseconds left out that will be executed now. So 5 plus 4, it will be 9. And after this, now P2 is over. P1 and P4 is left out. So in this, which is having the highest priority, P1 is having the highest priority. So P1 will be given the CPU. P1 will complete its execution. So you have 8 more left out. Okay, 8 more milliseconds left out. So 9 plus 8, it will be 17. And the final process to execute will be your P4. Now P4 takes the CPU, executes the process, and how many milliseconds left out? It is 15 milliseconds. Okay, so 17 plus 15, it will be 32 milliseconds. So it is over. Okay, so in a preemptive mode, in your priority scheduling, when a process with highest priority comes in, the previously executing the lowest priority process will be thrown out, and the process with highest priority will be given the CPU to execute. This is how it will work. Your priority scheduling depends on the priority value of the process. According to that, it works. So as you know, the next one to find out is the completion time. So completion time of your process P1, when it is getting over, it is getting over at 17. Here it is just, it was running for 2 milliseconds only. Now here only it is getting completed. So it is getting completed at 17. When is your P2 getting over? 9. And then your P3 is getting over at 5. And then your P4 is getting over at 32. So completion time is over. So what about the total turnaround time? You know the formula for the total turnaround time. Your total turnaround time is equal to completion time minus your arrival time. So what is the completion time? 17 minus 0, it will be 17. 9 minus 2, 7. 5 minus 3, it is 2. And then 32 minus 4, it is 28. So the next one we need to find out is the waiting time. So you know the formula for waiting time also. Waiting time is the total turnaround time minus the burst time. Right? So total turnaround time of process P1 is 17 minus the burst time is 10. So it will be 7. And then 7 minus 5, it will be 2. And then 2 minus 2, it is 0. Okay, it is 2 only, right? 2 minus 2, it is 0. And then 28 minus 15, it will be 13. Okay, now the waiting time is over. The next one which we have to find out is the average waiting time. So you have to add all these 4 divided by the total number of process. 7 plus 2 plus 0 plus 13 divided by 4. So it will be 5.5 milliseconds. And the next thing which you have to find out is the average total turnaround time. So it is 17 plus 7 plus 2 plus 28 divided by 4. Okay, so it will be around 13.5 milliseconds. So this is how your priority scheduling algorithm in a preemptive mode works. In the next video, we will see about some other priority, some other scheduling process. Thank you.